Hello, so today we're going to be going over the June 2019 Regents. We're going to primarily focus on the multiple choice questions. All right, so scrolling down, we're going to go one question at a time. And a lot of the Part A questions are repeated themes, so hopefully this will help you feel more prepared for the Regents coming up this week. Okay, so question 1. Which particles are found in the nucleus of an argon atom? Well, all nuclei are exactly the same, in which they have the same subatomic particles. So we can just ignore where it says argon atom. It's not really applicable. Okay, so in the nucleus, excuse me, in the nucleus we would see protons and neutrons, but we are not going to see electrons. Those are going to be orbiting on the outside. So just in that basic knowledge, we can see that choice 3 is the correct choice because the nucleus is only going to have protons and neutrons. Positrons are positively charged electrons. This only relates to nuclear chemistry. And of course, like I said, electrons are not going to be on the outs. They're only going to be on the outside. Question 2. Diagram below represents a particle traveling through an electric field. This may look familiar. I've put it on a couple of your exams. Ask which particle remains undeflected. This is an important word here, undeflected, when passing through the electrical field. So on this side, we have positive charge. On this side, we have negative charge. Now we know opposites attract and the same repels. So going through the options, if this was a proton, it would be attracted to the electrical charge, the negative charge right over here. Cannot be proton because it is not attracted there. An electron, because it's negatively charged, would be attracted to the positive field over here. But again, we see that the particle goes straight through without deflection. Cross that out. Now we're left with neutron and positron. Again, this is not a nuclear chemistry question, so it is not a positron. This is a positively charged electron. In that case, it would be attracted to this negative field here. The only thing that can go through and not be affected by charge is something that is neutral. So therefore, it's going to be choice 3, neutron. Question 3, we see a question like this about the mass of subatomic particles very frequently. It says the mass of an electron is blank. So when in doubt, check out table O, because they're going to tell you the masses, the different subatomic particles. And if you look, protons have a mass of 1, neutrons have a mass of 1, and electrons have a mass of 0. So the mass of an electron equal to the mass of a proton. Well, that can't be true because it's 0. Equal to the mass of a neutron, again, cannot be that choice. Greater than the mass of a proton, well, that's impossible. 0 is not bigger than 1. So therefore, we're left with choice 4. Electrons are less than the mass of a neutron. 4, compared to the energy of an electron in the second shell of an atom of sulfur, the energy of an electron in the blank. Okay, so when we're talking about different orbitals, let's say this is the nucleus, and this is an electron orbital, and this is an electron orbital. I've said before, imagine you're in a helicopter. I need to add energy to move up. Once I let go of the gas on that helicopter, I'm going to start descending down. So the energy in the first shell should be lower. So I'm going to mark that. We'll come back to that. Energy is never the same between different shells, so we're going to cross out 2. Third shell lower, well, that's not the case because the third shell will be higher, so there's going to be more energy. And of course, different shells cannot be the same, so we're left with choice 1. So again, as I move up, I need to gain energy. As I move down, I need to lose energy. And this is why when an electron moves from the excited state up in orbital down to the ground state, a lower orbital, light energy is emitted because I need to release that energy to move down. Question 5. In the ground state, an atom of which element has 7 valence electrons? So hopefully you can see on here, we're going to go down to our reference tables. We're going to look specifically at the periodic table. This is the wrong file. Here we go. All right, so again, we're going to scroll down. We're going to go down to the periodic table. I know it's sideways, so it's a little hard to see. But what we're going to be looking at is we want to see, again, the question asks, 7 valence electrons. Now, we know valence electrons are in the outermost shell. So we're going to look at the last number of the electron configurations. Well, right off the bat, we see that group 17, each one of these have 7 valence electrons. All of their outer shells have 7 electrons. So that means we need to choose something from group 17. So we can have the choices of fluorine, chlorine, bromine, iodine, antimony. Sodium is in group 1, not possible. Phosphorus is in group 15, not possible. Nitrogen is in group 15, not possible. So that leaves us with fluorine. Let's just double check. And we see fluorine does indeed have 7 valence electrons. So your choice is choice 4. Number 6, which information is sufficient to differentiate a sample of sodium from a sample of silver? Okay, this can be tricky because you might be drawn to number 1. You might say, well, sodium's got to be less heavy than silver. This is kind of like that riddle that they tell when you're a kid. Which weighs more, a pound of iron or a pound of feathers? A lot of people say the iron is heavier, obviously, but if you have a pound of each, they're the same. So we can't use mass to differentiate the samples. So let's cross that out. Similar to asking about volume. If they're both, let's say, 50 milliliters, then they're both going to have the same volume. So we cannot differentiate by volume. All right, so now we're left with choice 3 and 4, reactivity of each sample with water. I'm going to mark that because elements in different groups are going to have different chemical properties. So if we look, sodium's over here in group 1. And if we look at silver, it's in group 11. So they're going to have different properties. So that's probably correct. Number 4, the phase of each sample at room temperature. Now, we could, in other cases, use this property, but both of these are metals. So they're both going to be solid at room temperature. So we're going to cross out 4, leaving us with choice 3. 7, graphite and diamond are 2 forms of solid carbon at STP. These forms have blank. So this question is often on there as well. And graphite and diamond, so graphite would be pencil lead, and diamonds obviously are these beautiful gemstones. So they're both solid carbon. Now, diamonds and graphite are definitely different from each other. If you try to propose with a ring with graphite on it, probably going to say no. So they have to have different structures and different properties. So different molecular structures and different properties. Off the bat, we can choose choice 1. 8, as the first 5 elements of group 14 are considered in order from top to bottom, there are changes in both the blank. So let's go to group 14, orientate ourselves. Looking at group 14, they're all in the same group. That means they have similar properties, and they have similar properties simply because they have the same number of valence electrons. If you look, they all have 4 valence electrons. So choice 1, number of valence electrons and number of first shell electrons, there can't be changes in there because they're asking about changes. So that can't be 1 because they all have 4 valence electrons. 2, electronegativity values and number of first shell electrons. So we know as we travel towards the bottom of the periodic table, our electronegativity is going to go down. So that first part is true. The number of first shell electrons, let's take a look. 2, 2, 2, 2. So they all basically have 2 first shell electrons with the exception of lead. No, excuse me, lead also has 4 and the valence, but they have 18 as listed in the first shell. But we do see a dash here, and this indicates that there would still be 2 in that first shell. So let's cross that out. Number of valence electrons, again, that cannot be true. And then choice 4, electronegativity values and the atomic radii. This is why it's super important to know your periodic trends. So as I go down or across, my properties are going to change. So atomic radii is going to change and electronegativity is going to change. So therefore, we're left with choice 4 as our answer. All right, question 9. Which statement explains why sodium bromide is classified as a compound? So compounds need to be in a fixed proportion. And what this means is if I have something like H2O, there's always 2 hydrogens per oxygen, and I can't change that ratio. So going through NABR chemically combined in a fixed proportion, well, that sounds correct. But let's just double check the others. Sodium and bromine are both nonmetals. This is not true because sodium is to the left of the staircase over here, so that's a metal. And bromine's to the right of the staircase and is a nonmetal, so that's not the case. They're not, you can check this at table S, but sodium is a solid at room standard temperature and pressure. Bromine is a liquid, so we cannot choose that. But if we wanted to confirm that, we could look at the properties on table S. Sodium bromide dissolves in water at 298 Kelvin. Well, question 1 is going to be the better choice because I cannot tell if something's a compound simply because it dissolves. If we're looking at a compound, we're simply looking at its chemical properties. So 9 is choice 1. Which 2 terms represent types of chemical formulas? So when we're looking at chemical formulas, we have empirical, structural, and molecular. Molecular is going to be, let's say, as an example, H2O, just what you're normally used to. Structure is kind of like what we saw in organic chemistry, where you have the hydrocarbons. Empirical is when I have the most simplified subscript. So let's say I have H2O2. That's going to turn into HO because we can simplify those 2's. So let's take a look at the options for 10. Fission and fusion are nuclear reactions. I'm going to cross that out. Oxidation and reduction, those are also types of reactions, redox reactions, so that's no. Empirical and structural, of course, we have these as options, empirical and structural, so I'm going to choose that. Always double check the other choices. Choice 4, endothermic and exothermic, has nothing to do with formulas. Endothermic meaning I'm absorbing energy in the reaction, and exothermic meaning I'm releasing energy in the reaction. So all of these are examples of reactions except for 3. So you can use the process of elimination if you forgot what empirical and structural formulas are. All right, choice 11. During all chemicals reactions, charge, mass, and energy are, right off the bat, you should know this as habit, conserved. I'm going to cross out the others. Mass, charge, and energy are always conserved in a chemical reaction. 12. The degree of polarity of a covalent bond between 2 atoms is determined by calculating difference in their blank. Right off the bat, I'm going to tell you if you see polarity, it has everything to do with electronegativity. So it is choice 3. You see polarity, think about electronegativity. 13. Which substance cannot be broken down by a chemical change? If it cannot be broken down, that means it must be an element because elements cannot be broken down. If it says can be broken down, then you would look for a compound. So you might know this off the bat. You might know, okay, ammonia, methane, and water are all compounds because they all have chemical formulas. So ammonia is NH3, Water is H2O, and methane is CH4. Magnesium is just an element, Mg, so I'm going to choose that. Okay, always use the process of elimination if you have to. So if you forgot which one cannot be broken down, choose the one that's different. Also, if you didn't know, if you completely forgot and you're like, is ammonia an element? You can always check on table S to see if you see that name there. If it's not on table S, it is not an element. 14, which statement describes the components of a mixture? So mixtures are a mix of pure substances. Mixtures include suspension, colloid, and solutions. So let's go through the choices. Each component gains new properties. No, because it's a physical change, not a chemical change. So I'm not changing any of the chemical properties. 2, each component loses its original properties. Again, I'm not changing the properties. This is a physical change. The proportions of the components can vary, and the proportions of components cannot vary. So if the proportions cannot vary, then we're going back to the classification of a compound. Compounds have to be in that fixed proportion. So it cannot be choice 4. The proportions of the components can vary. So if I think about salt water, I can add a lot of salt to make really salty water, or I could put a pinch in there where I barely taste it, but they're both going to be considered a mixture. For choice 15, table sugar can be separated from a mixture of table sugar and sand and STP by adding blank. Separations of mixtures. So we're looking at 2 solids here. Now, if we're looking at solids, we can't use a filter right off the bat because sand and sugar are going to be trapped in that filter equally. Can't use distillation because that's used to separate liquids. We can't use evaporation because there is no liquid. So here's what we should do. What we should do is we should add water because we know sand does not dissolve, hence why we have beaches, but sugar can dissolve. So if we add water and stir it, we're going to dissolve that sugar and we're going to leave behind the sand. So we don't want to add sand. We do want to add water. So we're left with choices 3 and 4. And we're both stirring. Question is, are we distilling or filtering? If we distill this, we're going to be left with both solids again because we're getting rid of that water. So let's cross out choice 3. Choice 4 is your correct answer because you will then be left with, and I'll draw the funnel, you'll be left with sugar water here in your beaker. And in your filter, you're going to be left with the sand that did not dissolve. This is also a perfect example of why you cannot separate components of solutions using filtration because it's going to go right through that filter. Think about brewing coffee. I'm making a solution with the compounds in coffee, and that's why we use a coffee filter to leave behind those grinds, and what we're left is our delicious coffee. Question 16, which statement describes the particles of an ideal gas based on kinetic molecular theory? Okay, so one of my students told me this, and if you're watching, shouts out to you. But a way that you can remember the properties of an ideal gas, think about an ideal vacation. Ideal vacation, you probably want to go to an island somewhere and relax. So you want high temperature, low pressure. You want no pressure when you're out. Okay, so right off the bat, you should know those properties of an ideal gas. However, this question is asking about the particles. So according to kinetic molecular theory, I don't really have a volume. There's no force of attraction between the particles, and they're moving in straight line random motion. Those are the 3 pillars of kinetic molecular theory of ideal gases. So working backwards, particles are separated by small distances? No. Gases have large distances between the particles. Choice 3, the particles are closely packed together in a regular repeating pattern. That's a crystal. It has nothing to do with anything. And this would be considered a solid then. We're looking at gases. Choice 2, the force of attraction between the particles is strong. That cannot be the choice because we said according to KMT, there is no attraction between the particles. We're left with choice 1, which I'm going to circle. And this is one of the properties that the volume is considered negligible for each of these. All right, so for question 17, during which two processes does a substance release energy? So let's go through each of these. Freezing and condensation. So for freezing, I do need to release energy because I need to be colder. I need to release that heat. Condensation, the same thing. I'm turning from steam into liquid. I need to release that heat. So we know it's choice 1. Freezing, yes, I'm losing energy, but melting, I need to gain energy to melt. 3, evaporation, I also need to gain energy. 4, evaporation, I need to gain energy. So that eliminates 2, 3, and 4 and left with choice 1. 18, based on table I, which compound dissolves in water by an exothermic process? All right, so let's take a look at table I. All right, here we are at table I, and we see negative delta H's and positive delta H's. Now, a negative delta H indicates an exothermic reaction. That means I'm releasing energy. If I forgot that fact, take a look at the bottom. Read these footnotes. It says a minus sign indicates an exothermic reaction. So we need to figure out which one of these has a negative delta H. So let's try and find NaCl. NaCl has a positive 3.88, so that cannot be the choice. 2, sodium hydroxide. Looking at sodium hydroxide, it has negative 44.51. Right off the bat, we should know it's sodium hydroxide. Let's just check the others. NH4Cl, ammonium chloride, is also positive, so that cannot be the choice. Ammonium nitrate, also positive, so that cannot be the choice. We're still left with choice 2. 19, at STP, which property of a molecular substance is determined by the arrangement of its particles? When we look at the word arrangement, it is physical, and phases are physical. Half-life, no. Molar mass, no. Physical state is what we're looking for here. Physical state is the only thing that has to do with the arrangement of the molecules. 20, equilibrium can be reached by physical changes, nuclear changes, both physical and chemical, or both nuclear and chemical. Okay, we're looking at equilibrium. We're looking a lot at Le Chatelier. And we can have equilibrium in physical changes. So if we look at a heating curve, and you should know this for the Regents as well, these flat lines here and here are indicative of phase changes, hence why this is my heat of fusion, this is my heat of vaporization. And here, there's an equilibrium between solid and liquid, and here there's an equilibrium between liquid and gas. So we know we can have equilibrium with physical changes, but Le Chatelier told us we can have chemical equilibrium as well. So we can have a reaction indicated by a double arrow of which equilibrium is reached. So the forward reaction is going at the same or constant rate as the reverse reaction. So it can't be physical changes only because we also have chemical. Nuclear changes cannot be at equilibrium. Physical and chemical changes, this is choice 3. 21, which value is defined as the difference between the potential energy of the products and the potential energy of the reactants during a chemical change? Okay. So the difference between the potential energy of the products and the potential energy of the reactants. Well, let's pay attention to where it says chemical change. Chemical change. Heat of fusion, that's again melting and freezing. That's physical. Cross that out. Deposition is when I'm turning directly from a gas into a solid. Also physical because it's a phase change. Heat of vaporization right here is when I'm turning into steam or I'm turning to liquid water. That's also physical, so we can cross out 4. We are left with choice 2, heat of reaction. Number 22, the effect of a catalyst in the chemical reaction to provide a new reaction pathway that results in a different blank. You see catalyst, you think increase the rate of reaction. In order to increase the rate of reaction, I need to lower that activation energy. I need to lower the hill that I need to climb so it can be easier for me to reach the other side. So essentially, a catalyst helps you find a shortcut around that hill. Does not change potential energies, does not change heat of reaction, does not change any potential energy. It only changes the activation energy, how much I need to go up in order for the reaction to occur. 23, chemical systems in nature tend to undergo changes towards, this is something you have to remember, but we want lower energy, higher entropy. Entropy is a measure of chaos. So if you notice, you leave a bicycle outside, it's going to rust. You leave a car alone, it's going to break down. If you leave your body alone, it will start to break down. We are always moving towards chaos and disorder. Your job as a biological organism is to fight that second law of thermodynamics, and you want to keep yourself organized to sustain life. If left to nature, you are going to decompose. Entropy is going up. Lower energy, anytime you have something hot, it's going to dissipate. So that heat energy is going to be released to the surroundings. Long story short, we want to choose the one that has low energy, high entropy, which gives us choice 2. 24, the atoms of which element bond to one another in chains, rings, and networks? You see chains, rings, and networks? Remember this? Think carbon. Choice 2. 25. What is the general formula for homologous series that includes ethene, E-N-E? This is an easy question because we can find this on our reference tables. Ethene listed right here, and it tells you the formula is CnH2n. So this is a give me question if you know how to use your reference table. So make sure you know which table is what. 26, when a fluorine atom becomes a fluorine negative ion, the fluorine atom blank. Electrons have a negative charge. If I'm adding electrons, becoming more negative. If I take away electrons, becoming more positive. Because I turn into a negative ion here, that means I had to gain an electron. 27, which substance is an Arrhenius base? Okay, when we think about Arrhenius base, we're going to look for OH at the end of my compound. If you forgot this, look at your handy-dandy reference tables. And you see common bases usually end in OH. All right off the bat, if you looked at table L, you would know calcium hydroxide, CaOH2, is your choice. So I can circle that automatically from the reference tables. Do not make the mistake of choosing this one, although it ends in OH. If we look at our reference tables, it tells us this is ethanoic or acetic acid. This is an acid. Organic acids are going to end in COOH, so be very, very careful. 28, in which type of nuclear reaction do 2 light nuclei combine to produce a heavier nucleus? So we're combining 2 nuclei, we're fusing them together, so we're going to be choosing fusion. Fission, on the other hand, is when I collide those particles and they break apart. 29, using equal masses of reactants, which statement describes the relative amounts of energy released during a chemical reaction and a nuclear reaction? Okay, let's think about that again. If I use equal masses of reactants, which describes relative amounts of energy during a chemical reaction and nuclear reaction. Okay. Choice 1, chemical and nuclear reactions release equal amounts of energy. Not sure that's true. A nuclear bomb is going to release a lot more energy than a conventional combustion bomb. I'm going to cross that out. Nuclear reaction releases half the amount of energy of a chemical reaction. We don't know that. And also nuclear reactions wouldn't be less, so no. 29, let's see. Choice 3, the chemical reaction releases more energy than the nuclear reaction. That is not true either. Nuclear reaction releases more energy than a chemical reaction. That is true. Now, the reason why we're able to make this comparison is because equal masses. So, all it takes for a nuclear reaction is one particle and one particle. Tiny, tiny, tiny collide, huge amounts of energy because I'm converting mass to energy. Chemical reactions, on the other hand, if I took one magnesium and one chlorine and chemically combine them, it wouldn't release as much energy like a nuclear reactor or nuclear bomb would. 30. The ratio of the mass of uranium-238 to the mass of Pb-206 can be used to blank. Okay, now ratio of masses, we're going to automatically think about half-lives. So let's take a look at what the half-lives of those are. So we're going to go to table N, and we're going to look for uranium-238 has a half-life of 4.47 times 10 to the 9th. That is a very long time. I believe you're looking at the billions of years. Pb, lead-206. Let's take a look. Pb. Well, I do not see it on our list. So the question is, what do I do at that point? Well, if we look, they're both being put into the same category. I can't use to diagnose thyroid disorders because the half-life is way too long for uranium-238, just way too long. So I'm going to cross that out. Diagnose kidney function, same thing. By the time you're able to diagnose, you would be long, long dead. Date geological formations. This is an option because if we're looking at millions or billions of years, then we can date geological formations quite easily with that radioisotope. Date once living things. It's less easy to determine that using something with such a long half-life. So I'm going to cross that out. The better choice here is going to be choice 3, date geological formations. 31, also a common question. When we're looking at bright line spectra, in order to determine which of these elements are contained within the mixture, I need to see if all of that element's lines match up with the mixture. So let's take a look at G. This line matches up. This line matches up. This line matches up. And this line matches up. Element G, definitely is in there because all of its lines match up with the mixture. Let's look at J. These two lines do not match up with the mixture, so it cannot be J. Let's look at L. These two lines do line up with these two lines in the mixture, so it is in there. Element M. This does not match up. This does not match up. This does, and this does, and these don't. It's all or none. If some of them do not match up, it is not in there. So therefore, we're left with G and L, which gives you choice 2. Which electron configuration represents an atom of chlorine in the excited state? So we need to look at the electron configuration of chlorine first. So let's scroll down. Electron configuration here is 287. I'm going to write that down. Please make sure you know the difference between excited and ground states. You're going to almost always see a question asking, what's the electron configuration in the excited or in the ground state? When we become excited, one of these electrons is going to hop up to the next orbital. So in order for me to be in an excited state, I'm going to move from the second lowest orbital to the highest. So I'm going to get the electron configuration of 278. Gives us choice 4. 33. A student measures the mass and volume of a sample of aluminium at room temperature and calculates the density of aluminium to be 2.85 grams per cubic centimeter. Based on table S, what is the percent error for the student's calculated density of aluminium? If you forgot how to calculate percent error, there is a formula here on table T, which is measured minus accepted over the accepted times 100. So the measured value was 2.85. I'm going to get my accepted value from table S. So what we need to do is we need to find aluminium on table S. So I'm going to keep on scrolling through until I see it, which I see it right here, atomic number 13. And I'm going to scroll over to its density, which we see is 2.7. Now I'm just going to double check. 2.7, we're good. Put that over 2.7, which is also the accepted. And now all I have to do is use a calculator to make my calculation. So 2.85 minus 2.7, I'm going to get 0.15 over 2.7. Which gives us 0.055 repeating. In order to convert this to a percentage, again, we're multiplying by 100, move the decimal point over, and we get roughly 5.6% because we can round up. 34. Magnesium and calcium have similar chemical properties because their atoms in the ground state have blank. If they have similar properties, it's all about the valence electrons. So we're looking at 4, outermost shell valence electrons. 35, as elements in period 2 of the periodic table are considered in order from left to right, which property decreases? As I move to the right, atomic radius is going to decrease. Looking at the other trends, ionization energy is going to increase moving to the right. Electronegativity is going to increase moving to the right. Nuclear charge has nothing to do with it. 36. Given the balance equation of the reaction of butane and oxygen, how many moles of carbon dioxide are produced when 5 moles of butane react completely? When you see a question phrased like this with a chemical formula, you're looking at a mole ratio question. So you're going to set up a proportion. On the left-hand side, I like to write what I find from the equation. So we're looking at carbon dioxide to butane. So there's 8 carbon dioxide in that equation, and there is 2 butane. Now on the right side, I'm going to write what the question gives me. So it says how many moles of carbon dioxide, so I'm going to put that as X. And it says I now have 5 moles of butane. Now I'm just going to solve the proportion. Always double check with a calculator because sometimes arithmetic gets a little wonky when you're testing. But we get 40 equals 2x, divide by 2, and we're going to get 20 moles. What is the percent composition by mass of nitrogen in the compound N2H4? It gives you the gram formula mass. All right, so the formula for this is going to be found on table T. Percent composition by mass equals mass of part over mass of whole times 100. Our part is going to be the total mass of nitrogen. That's what the question asks you. So that means I have 2 nitrogens here. So I need to include on the top the mass of 2 nitrogens. If we look at our periodic table, we see nitrogen has a mass of roughly 14. So therefore, I'm going to have 28, because I have 2 of them, on top, and we said the bottom number is going to be 32. I'm going to multiply that by 100. I'm sorry, this 2 is horrible. Okay, so if we plug that into a calculator, 28 over 32, we roughly get 87.5 in our calculator, so we can round that up to 88%. 38, which ion in the ground state has the same electron configuration as an atom of neon in the ground state? So we need to find one of these ions that has the same electron configuration as neon. So if we look at neon, it has electron configuration of 2-8. All right, calcium 2 plus. This is saying I lost 2 electrons. Calcium is electron configuration of 2-8-2. If I took away those 2 electrons, I'm left with 2-8-8. That does not equal 8. Chlorine negative, so I added an electron. So chlorine normally is 2-8-7. If I add an electron, now I have 2-8-8. Also cannot be true. Let's look at lithium plus. So lithium, I'm going to be taking away an electron because I'm becoming positive. So now I have an electron configuration of just 2. That can't be the case either. Oxygen 2 minus. Oxygen is electron configuration of 2-6. If I added those 2 electrons, I would get electron configuration of 2-8, which is perfect. That is our choice. 39. Which compound has the strongest intermolecular forces? Strongest, you're looking at hydrogen bonding. Hydrogen bonding is not a type of bonding, it's a type of intermolecular force. For hydrogen bonding, I need hydrogen and either fluorine, oxygen, or nitrogen. I call this FON. So we're going to look for each one of these compounds that has both hydrogen and either fluorine, oxygen, or nitrogen. In this case, it could be hydrogen fluoride. Question 40, which particle model diagram represents xenon at STP? Xenon is one of the noble gases in group 18. If I forgot it's a gas, I can look at its properties on table S. So right now we're looking at a gas. Now 3 and 4 look like solids to me because they're in a range pattern. These guys are random. The question is, should I choose the one that has 2 xenons bound or just 1 xenon bound? This is a tricky question. Xenon itself has 8 valence electrons. It's stable. It does not want to make any bonds with anyone, including itself. So it's choice 1, not choice 2. But I'm going to annotate here, O2. If it asks you which one represents oxygen gas, oxygen cannot exist just by itself as O. We know oxygen gas, what we breathe in is O2. In that case, we would choose the 2 that are bound. And if we chose choice 1 for that case, we would be wrong. So make sure you're paying attention to that. But for question 40, we're looking at a noble gas. It exists by itself. 41, what is the amount of heat absorbed when the temperature of 75 grams of water increases from 20 to 35 degrees? We're going to look at table T. That's going to give us all the formulas. All right. For heat, my 3 choices are, do I use MC delta T, MHF, or MHV? Always look to see if there's a temperature change. If there is a temperature change, automatically we're going to choose MC delta T. So there is a temperature change, so I know I have to use Q equals MC delta T. Now I just plug everything in. We're solving for Q. I have 75 grams of water. For C, it says C is the specific heat capacity. If we scroll up to table B, we see specific heat capacity is 4.18. And the temperature change is final minus initial. So 35 minus 20, which is going to equal 15. So now we plug into our calculator and we say, okay, 75 times 4.18 times 15. It's going to roughly give us 4,702.5. We can just choose 4,700. Question 2. Which sample of hydrochloric acid reacts at the fastest rate with 1 gram sample of iron fillings? If you increase anything, you're increasing the rate of reaction. So we want to look for a high concentration, high temperature. In this case, the highest would be choice 4. I have a higher concentration and a higher temperature. No matter what, if I increase something, the rate of reaction is going to be higher. So always choose whatever has the highest levels, highest concentration, highest pressure, highest temperature, etc., etc. 43. Given the equation representing a system at equilibrium, which statement describes the concentration of the two gases in this system? If they're at equilibrium, the concentrations must be constant. One cannot be greater than the other because they're equal at equilibrium. But here's the trick. The concentrations are not always equal, but they are constant. If you look, dinitrogen tetraoxide, on the left-hand side, I only have 1 mole. On the right side of nitrogen dioxide, I have 2 moles. They don't have equal concentrations. I have more nitrogen dioxide than I have dinitrogen tetraoxide. But if I'm at equilibrium, this reaction is going at the same rate forward and reverse. So those concentrations must be constant, not equal. Do not make that mistake. That's a trick question. 44. Given the equation representing a system at equilibrium, which change will cause equilibrium to shift to the right? So I want to go this way. This is Le Chatelier's principle. Now, if I add a catalyst, I'm speeding up both reactions, both the forward and the reverse. So one isn't going to be practical because I want to shift it to the right. If I add more PCl3, if I made my teeter-totter, and now I have more PCl3, so that side's going to be higher. Well, I need that side to go down and the other side to go up in order to balance out my seesaw. That means that this reaction producing PCl3 needs to go down. So that cannot be the case. Increased pressure versus increased temperature. Now, increasing pressure, you think high, high, low, 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 high. If I have high pressure, I have high pressure, I'm moving from high number of moles of gases to low number of moles. Both of these are gases. We have 2 moles of gases on the right, 1 mole of gas on the left. If I had high pressure, it'd be going towards the left, so that's not the choice either. If I increase the temperature, I still have my seesaw. Now the left side is automatically higher, so the left side needs to go down and speed up the reaction towards the right, so it's going to be choice 4. 45. Given the formula representing a molecule, the chemical name for this compound is blank. First of all, let's count how many carbons we have. So we have 1, 2, 3, 4, 5 carbons. So we know we're going to have a pent in the name. How do I know this? Let's look at our reference tables. We see 5 carbons equals pent. Also, we have a functional group. Functional groups are identified as anything that's not a hydrocarbon. So if I see a different element than just carbon, there's a functional group. So I have this nitrogen here bound with the H's. If I look on table R, I'm going to look for the one with nitrogen. And it's either amine or amide. But amide needs an oxygen. I don't see an oxygen here. So we know it's an amine, which means, according to this table, it has to end in amine. So I'm going to write amine, it has to be in the name. Now we look and see which one has pent and amine in the name. The only one that does is choice 3. All right, we're almost done with the multiple choice. Given the formula of a compound, this compound is classified as a blank. This is a give me question. If you know how to use your reference tables, table Q tells us single bonds of an alkane, double bonds of an alkene, triple bonds of an alkyne. We see we have a triple bond, so therefore it has to be an alkyne. 47, which equation represents fermentation? I guarantee you there's going to be an organic reactions question on here. Use your notes to memorize those. Now, fermentation, I'm turning sugar into alcohol and carbon dioxide. I only see one of these with a sugar, which is choice 3. Only one of these produces carbon dioxide. So even if you forgot how to identify that this is an alcohol, you can still choose choice 3 because you see the sugar and you see the carbon dioxide. 48, given the equation representing a reaction, the oxidation number of copper changes from blank to blank. So let's assign oxidation numbers. All right, so we're trying to find copper. Starting off with chlorine. We know chlorine has to be -1 when combined with a metal. Because I have 2 chlorines, that gives me a total charge of -2. In order to balance this out, that means I need a total charge of +2 on the left. So therefore, this copper has to be +2. So now we're left with choice 2 and choice 3. Now we have on the right side copper by itself. If you are by yourself, you are nothing. You are 0. So choice 2 is your choice. 49, given the equation representing a reversible reaction, according to one acid-base theory, the 2 H+ donors in the equation are blank and blank. This one's harder. Now we can remember bad. Bases accept, acids donate. So we want to look for the ones that donate in this reaction. So if we look, CH3COOH turns into CH3COO. We lost that hydrogen. So we know that we donated that hydrogen. So it has to be one with that acid. Okay, looking at the other side, we see H3O turns into H2. So one of the hydrogens is lost. So that gives us option 2. Now, looking at the bases, just for argument's sake, H2O is turning to H3O, so it's actually accepting that proton. It's accepting that hydrogen. And in this case, we see that CH3COO is turning to CH3COOH. So again, I have to accept that hydrogen. So this is a base, and this is a base. This is an acid. This is an acid. Question 50, which nuclear equation represents a spontaneous decay? Use process of elimination to your advantage. So if it's spontaneous, aka natural, I'm not adding anything to it because I don't need to make it go. It just does it on its own. So automatically we can choose 1. If you forgot that, the only one that only has 1 reactant is going to be choice 1. Choice 2, 3, and 4 all have 2 reactants. All right, well, I hope that this was helpful. And happy studying. Let me know if you have any questions, and good luck.